Hello, friends. Welcome to my Flutter course. Today, we have a very important topic, working with JSON in Flutter. JSON is one of the key formats for data exchange in web applications, mobile apps, and even in smart home devices. Therefore, knowing how to work with it is essential for any developer. So, what is JSON? JSON stands for JavaScript Object Notation. It is a text format that allows you to store and transfer data. Its main advantage is simplicity, as the data is represented in a key-value format, much like storing in a map collection, which we've covered before. Here's an example of a simple JSON. JSON objects are wrapped in curly braces, and the data is listed with commas. The data can be of any type, such as strings, numbers, or Boolean values. We can also use more complex objects by passing another JSON with its own values. Here's what it looks like. We can also pass lists using square brackets. Now, let's see how this can be implemented in Dart and Flutter. First, let's create a simple map collection. Notice that we will use the string type as the key and the dynamic type for the values. A variable declared with the dynamic type can hold values of any type. Let's assign some values to our map. Since we are using the dynamic type for the values, we can pass strings, numbers, Boolean values, and generally any value. This way, we have a map variable that holds a simple set of data. Now, to convert our variable into JSON format, we need to use the JSON encode method, which is built into Flutter. This method returns a string, as essentially any JSON is just text. It accepts an object of type object as a parameter. As we remember, this is the class from which all Dart classes inherit implicitly, even the ones we create ourselves. This allows us to pass anything into this parameter. In this case, we will pass our map variable. Let's print the result to the console. As we can see, the output is text representing the JSON that holds our set of data. Note that if we simply print our variable without the JSON encode method, it will print differently, specifically without quotes. Now, let's create a string variable and assign it the value of JSON, which is based on our map. This way, we have information stored as JSON in the variable. But now, we can do the reverse process, converting JSON back into a map. Let's create a new variable with the same type, a map with string keys and dynamic values. We'll use the JSON decode function to assign it a value. This function accepts a JSON string as a parameter and returns an object of type dynamic, meaning it can return various objects of different types depending on the JSON provided. Let's pass our JSON string into it and then print our new variable to the console. After rerunning the code, we see that everything works and we successfully created a variable based on JSON. However, working with map variables can be inconvenient, so classes are usually used. Now, let's see how to work with JSON when we have a class. For this, we will create a simple class. Now, let's create its instance. What do you think will happen if we try to print the result of the JSON encode function by passing our class into it? Rerun the code, and we see that this leads to an error. The reason is that this function doesn't work with all types and doesn't work with classes that we create ourselves. Therefore, we need to implement this mechanism manually. It's not difficult. In the future, we will use libraries for this, but for now, let's see how to do it manually. First, let's write a function that will return JSON from our object. The type of this function will be map, the same as before. This type is very similar to the structure of JSON because, like JSON, it has string keys, and the values can be of any type, such as string, int, double, bool, lists, or even other nested objects. Inside this function, we will return a map where we manually specify the keys and assign values from our class. Here's what it looks like. Now, let's create a mechanism so that we can convert JSON back into an object. For this, we will use a factory constructor. We'll name it from JSON. It will take an object of type map as a parameter, the same type we use for JSON. Inside the constructor, we will return an instance created via the regular constructor. But we need to get the values for the constructor from somewhere. We will use our parameter, specifically the map. As we remember, we get values using the key passed in square brackets. In this case, the keys are expressed as strings. Here's what it looks like. Notice that the key must match the one we use in the toJSON method. Now, let's test our methods. First, let's create a string variable that will store the JSON of our object. We'll use the JSON encode method and pass the result of the toJSON method of our variable into it. Notice that no error should occur now because we are passing a map into JSON encode, not a person object. Let's print this variable to the console and see what happens. As we can see, JSON containing the data from our variable is printed. Now, let's use this JSON to create an instance. To do this, we need to use the factory constructor and pass the result of the JSON decode function, passing our JSON string into it. Now, let's print some field from our second variable to the console. After rerunning the code, we see that everything works. Now, let's look at how to store a list of objects as JSON. For this, we'll create a list of person objects. This part might be a little confusing, but don't worry if you don't get it right away. It's a rather complex topic, but after a little practice, you'll understand everything. We need to create a list of JSON objects from our person list. In other words, a list of maps. Yes, we can create collections from other collections. Here's what it looks like. We also don't forget to specify the generics of our map. Now, we need to convert our original list into this type. We need the toJSON method to be called for each element in the original list, which will return the required map. For this, there is a map method available for collections. We've covered this in previous lessons. This method takes a function with one parameter, which is the same type as our list. Inside this function, we will return a value. This is where we will call the toJSON method. As we remember from previous lessons, the map method returns not a list, but an iterable object. So we need to use the toList method at the end. Thus, we've created a list of JSON based on a list of person objects. Now, let's create a string variable that will store the final JSON. As a value, we'll call the JSON encode function and pass our list of JSON into it. Now, let's try printing this to the console. After running the code, we see the result. It's a JSON string representing our list. Now, let's do the reverse. convert this JSON into a list of person objects. We can do this with the following syntax. First, we call the JSON decode method to convert our string into a list, since this JSON stores a list. Next, we need to use the map method, but a little differently. However, since the object returned by JSON decode is dynamic, we cannot directly call the map method. To do this, we first explicitly convert it to our list using the as keyword. Here's what it looks like. The logic is as follows. The string holding the JSON is essentially decoded, but it does so as a dynamic type, meaning it could be any type. But we know it should be a list of objects, so we explicitly specify that it's a list. Then we call the map method on this list. Inside this function, we return the result of the factory constructor, passing the function's parameter. And don't forget about toList. Now, let's try printing this to the console. After running the code, we see that everything works. So today, we've learned what JSON is, how to work with it in Flutter, and covered data serialization and deserialization. Don't worry if you didn't understand everything. When we practice with real examples, everything will become much easier. Don't forget to subscribe to the channel and click the bell so you don't miss the next lessons. In the next video, we'll cover how to work with animations and make your apps even more attractive. See you in the next lesson. Let me know if you need any further adjustments.